Hi, in this video we are going to go over the solution of the problem 122nd, best time to buy and sell a stock second. So the problem statement tells us that we have an array of numbers and each number presents the value of a stock. And we want to see how we can accumulate more profit from buying and selling. So we can have multiple transactions, we can multiple times buy and sell, but those transactions we cannot buy a lot of stocks at the first and sell at the end. So we have to have a kind of a buy sell. So for example, for this example here, I can buy at 1 and sell at 5 and get the profit 4 and save that. And also I can buy at 3 and sell at 6 and accumulate the price here. So in total I have 7 profit. Or for this example, I can buy at 1 and sell at 5. So I can have the profit 4, and this example at the end, so I cannot have any profit because price is coming down, so we output 0. So the idea to solve the problem is that we compare two consecutive actions. For example, 7 and 1, so it's decreasing, there is no buy and sell here. So but when I'm here from 5 to 1, I can say okay, 5 is greater than 1, so I can say I buy at 1, sell at 5. Then I come and compare 5 and 3. This is decreasing. I don't care about it. I go here. This is increasing. Okay, I say buy here, sell here. So if buy and sell are adjacent nodes, that is easy. But if they are not, so something like here. So I have 1, 5 here. So I want to buy at the first one, and then I want to sell it when I'm reaching to the price 5. So the price that is different, the difference price between these two is actually all of the differences between all two nodes between them. So technically, if I buy and sell at 2, buy and sell at between 2 and 3, buy and sell at between 3 and 4, and buy and sell at between 4 and 5, I get the exact same profit if I buy at here and sell it at here. That trick helps us a lot in having a very concise solution. Okay, let's start writing the code. So the first thing that I'm gonna do is that let's put the first example, and we call the variable prices, and I'm going to start a class solution and define a function max profit prices, and then I'm gonna define a variable. I call it total profit 0, and now we start comparison, and we say for I in range, I should compare two things. So I'm gonna start from the second index, which is 1 to the length of prices. I go forward and say if prices I is greater than prices I minus 1. If, for example, 2 is greater than 1, in that case, I come and say total profit plus equals what? The difference between these two. Okay, and then at the end, for the function, I can just return total profit. S1 equals solution, and I can just print S1 dot maximum profit of prices. Let's see what we get. Okay, we get 7. Why? Because I have 1 profit here and 1 profit here, and as we expected here, we get 7. Let's try that for another example. So for the second one, we get profit 4 because we accumulated this one, and this one, and this one. Okay, so let's try that for the last example. We should get 0. Yes, because we define by default total profit be 0. So there is no if statement true for this example. The total profit remains 0. So the time complexity of this problem is what? Is order of n, because we only go 1 through the list. So that is this for loop that we have. Okay, and space complexity is what? Is 1, because we are not making any arrays or any structure to record the data. It's just a simple comparison. Okay, this is the solution to the problem 1/22, and again we could buy and sell stocks multiple times, but we cannot buy all of them at this one time and sell all of them at the end. And the trick was to compare every 2 elements of the array, and if it is increasing, we add that to our profit. And we said that for a situation that we want to buy, for example, here and sell here, that is equal to accumulating profits between every 2 elements. For example, between 1 and 5, the profit equals to the between 1, 2, 2, 3, 3, 4, and 4 and 5. Okay, considering that trick, so we should be able to solve this problem like this, and we solve the time complexity and space complexity. Thank you so much for watching this video.